In this video, I'm going to show you what you need to do to connect a rotary chuck up to a large format CO2 laser machine. Hey everyone, welcome to the Laser Channel where we learn, create, and share. My name is Greg and let's get started with getting this installed in the machine. The first two obstacles we're going to have to overcome though is getting this to turn smoothly and the correct distance. The next hurdle we have to overcome is getting the laser bed of the machine low enough so that the laser head will clear over the top of the rotary chuck. I'll start by just loosely placing the rotary chuck inside of the machine. We're going to check out this setup later on, but just mainly showing that I'm going to be running the cable just as I would if I had a rotary roller. I'm running the cable back to this corner because that's where the accessory gets plugged in. Check this out. I took a quick peek out the window while I'm recording. I've got a bunch of deer in the backwoods here. Well, back to the video. Pretty straightforward so far. I've got the rotary chuck simply placed inside of the machine. It's connected up to the accessory port. I've also went from that accessory port and I traced the wire down so that I know what motor drive it's being connected to, because we're going to need to make some adjustments there, which is the secret on getting the rotary chuck compatible with the laser machine. The compatibility issue comes into when we talk about the step count of the motors on the machine itself. This one, there's something like 3,200 or 6,400. The rotary chuck, the step count there is going to be 12,800. Because those don't match, this is never going to turn smoothly and it's never going to turn the correct amount. So for that, I'm going to go and take a look at the motor drive that I'll be using for the rotary chuck. The motor drive in the machine is going to look something like this. It's going to be a little black drive. Typically, it's got green connectors coming out of it, and it's going to have two charts on it. The top chart is going to be the max current that goes out to the motor, and the bottom chart is going to be the step count of the motor being connected up to it. We're going to be concerned with the bottom chart, and in its most simplistic state, I'm going to adjust the dip switches on the side so it matches what I need for a motor with 12,800 step count. Just keep in mind, if you use the motor controller that is inside of the machine, you're going to constantly have to switch the dip switches between using the machine for its regular flat work versus having that rotary chuck set up on it. And from my experience, the little levers on these dip switches, they eventually will break. So what I highly recommend doing is going out and spending about $30 on one of these, get a second one, and then simply swap out the entire drive. I think it'll help if we take a look at two stepper motor drives that I have in the shop here. Both of these are compatible with my machine, even though the model number of each of these is different and neither one matches the actual machine, and that's okay. The main difference is going to be when we take a look at this one, the top chart, the current's going to go from 1 amp to 5 amps. This other one is going to go from 1 amp to 4.5 amps. So I just have to make sure that I pay attention to when I set the dip switches on the side. To find what current you need to have your dip switches set, take a look at the motor drive that's already installed on your machine. Take a look at that. On mine, it's going to be about 2.25 amps. So on here, I'm going to find what is the closest one, and we're going to see I've got 2 amps and 2.5 amps. So I'll actually pick the one that is lower, so I would set the dip switches to 2 amps on the side of the controller, and then I'll be all set. Here's a look at my electrical cabinet, and before I dive in here, safety first. I have the power turned off on the machine, and the cables are actually disconnected. And that's because my power switches for the machine are located up in that direction. The power cables are connected way back here, which means if the machine was plugged in, there would still be live power running throughout the cabinet, so safety first. I traced the cable back that the rotary chuck is connected up to, and it's going to go to this bottom drive. I did double check the current that this drive is set at. I think it was set at 2 amps. It's actually going to be 3.5 amps. That's why it's important to check out what the machine is currently set at. On the drive I'm going to be putting in, I took a look at the dip switches and updated this one for 3.5 amps. I checked out the bottom chart and made sure that it is set to 12,800 step count, with the dip switches located on the side right here. And from here, all I need to do is pull the cables out and transfer them over to this new controller. I'll let that sit at the bottom of the cabinet, and from here, I'm ready to jump into the computer and get the machine powered up. Time for power. When the machine powers up, just like it always does, it's going to want to home the laser head. However, the rotary chuck doesn't have a homing switch on it, so I'm going to interrupt that homing sequence by hitting the escape button on my control panel. We'll check out the controls real quick. The X-axis, that works like it normally should. Now the up-down keys, that now controls the rotary chuck, and we're going to see it turns nice and smoothly. In the computer, it's now time for some light burn action. We're going to be checking out Enable Rotary. I can do that here or at the top of the screen. If you don't have this showing up in your computer, you can go over to Edit, Settings, Display, and then we can check this on, Show Rotary Enable on main window. That's going to be this right here. And that's also a good idea to show Cylinder Correction Enable on main window as well. For now, I'm going to go up to the top here and click on the rotary setup. And I'm going to make sure that I have the chuck enabled. It's on the Y-axis, and the steps per rotation, 12,800. Because I'm using a rotary chuck, I do need to measure the diameter or the circumference of the cup. I recommend measuring the circumference. It's going to be a lot more accurate. I would enter that in right here. The only thing that I would do after this, if I've never set up the rotary chuck, is I would take the text tool and I would simply write down the number 2. I'll make that a little bit bigger so that we can see it. And I would rotate this so that the top of the 2 is going to be the top of the opening of whatever I'm engraving. I'm going to do just a test engraving of this to make sure that the letter 2 shows up correctly. If it shows up correctly, I'm free to start creating with the rotary chuck. If it's backwards, I'm going to go back to Rotary Setup and click this button here, Mirror the output to the rotary. I've already done this off camera. Mine does not have to be mirrored. I'm going to go back into Rotary Setup one more time and make sure that I actually do have it enabled. Now, from here, I'm able to go and create all of my projects. For me personally, I've got 2 cases of these that I need to do. Once I'm done with that, I need to uninstall the rotary chuck to go back to doing regular flat work to make sure that the machine operates correctly and it's not stuck in rotary mode. I'm going to go back up to the rotary setup and I'm going to turn off Enable Rotary. Then I can close out of the computer, turn the machine off, switch those stepper motor drives back, and the machine is back in its original configuration. That takes care of the first part of the video of getting the rotary chuck to turn smoothly and the correct distance. Now, if I didn't match the step count of the rotary chuck up to the machine, what would happen is when the rotary chuck indexes for the next line of engraving, it's going to actually wiggle a little bit. And of course, trying to engrave on something that's wiggling back and forth, the results are very poor. And by the way, I'll have some links down in the video description of some typical stepper motor drives that are compatible with these CO2 laser machines. Nothing replaces checking out the model number on your machine and finding an exact duplicate. But if you can't find that, just find something very similar, making sure that you can match the motor current and the step count of the motor. Don't worry, I haven't forgotten about the second part of the video, and that is how to get that big rotary chuck to fit inside of the machine. For that, we're going to open up the lid and check out what I did. Here's some of the steps that I went through to get my rotary chuck to fit. I first started out by just simply placing it on top of the honeycomb and lowering the machine bed down as far as it could go. I still had nowhere near the height clearance that I needed between the laser head and the rotary chuck. I pulled the honeycomb out, set the rotary chuck on top of the knife blades, still didn't have the clearance that I needed. And then I saw that in my crumb tray area, there's a ledge that goes all the way around that's underneath the knife blades, and I cut a board that fit exactly. I placed my rotary chuck on top of that, and now I've got just enough clearance. I mounted my rotary chuck down to a board so it positions around without tipping forward, and then I just used 2 clamps to secure it down to this board inside of the machine. And I understand that your machine might not have this lip or this edge that goes all the way around. So in some cases, we might have to go all the way down on the crumb tray in the very bottom of the machine, and we might actually have to stack up some wooden blocks or something to put the rotary chuck on there. Essentially, the process here is taking a look at what we can easily pull out of the machine to get the rotary chuck low enough for the laser head to clear over the top. Well, that just about wraps up this video. Thanks for joining me, and I hope that you'll keep this video around for reference on connecting a rotary chuck up to a CO2 laser machine. Be sure to share it when you run across others trying to figure this out as well. I hope that you enjoyed this video. If you did, don't forget to show it some love by giving it a like, subscribing to the channel. Not only is it a great way to help this channel grow, it's an awesome way to connect video content like this with other great viewers just like you. And until we meet again in the next video, I'm Greg from the Laser Channel, where we learn, create, and share.